Hey everybody. I want to continue on with the rational expressions. So in this video, I'm going to start out with two problems where we're just going to simplify. Then we're going to look at what happens when we multiply and divide rational expressions. So if you remember, for simplifying, your very first step, and this actually goes for all of these problems, your very first thing that you want to do is you want to factor all of your expressions. So the key to these is factoring. Because if you remember, once you factor, anything that you have alike on the top and bottom, you get to cross out. So what I'm going to do here is with the top, I'm going to take out a GCF, which is x. And if I take an x out of each of these, I have x plus 6 left. So that's what the top looks like now. On the bottom, I have to factor, and this is x and x. And then remember, you're trying to multiply to get 54, add or subtract to get the negative 3. So the numbers I can think of for 54 are 9 and 6. So to get negative 3, it's going to be negative 9 plus 6. And this works out really well now because what you are going to see happen here is you are going to notice that on top and bottom, you have the same thing. So this x plus 6, these can go away. So this simply becomes x over x minus 9. So that's our simplified form there. Now, for this second one, again, we want to factor, and I mentioned this in the last video. You can either write them out beside, or I usually factor above and below. So to get 2x squared, I'm going to have 2x and x. Factors of 3, I'm going to have 1 and 3. So I think I'm going to put the 3 here and the 1 here, because that gives me 6 and 1. So negative 6 plus 1 is negative 5. On the bottom, this is a regular factoring. Factors of 6 that add up to 5. That is, that is 2 and 3, and they both have to be negative. So here what I see is I have x minus 3, x minus 3. So those cancel out. So what I'm left with is 2x plus 1 and x minus 2. So there's our simplified version. So now what we want to do is we want to be able to multiply rational expressions. Now remember, the word rational should make you think of a fraction. So essentially we're multiplying fractions. So the first thing that I want you to think about is remembering how to multiply fractions. So if we have 1/2 times 1/3, when you multiply fractions, you just multiply straight across and you get 1/6. So what this might look like, let's say we've got 2/3 times, let's go with 5/6. Okay. So what happens here is you could multiply this straight across and call it 10/18, but then you're going to have to simplify. And we know that we can divide both of those by 2, so we end up with 5/9. So that's one way to think of it. Now, another way that you can do this is if you have 2/3 and 5/6. 2, 3, and 5, those are all prime numbers. I can't simplify those any. But 6, I can split down into 2 times 3. Now, the way that this works with multiplication is it doesn't matter which fraction it's in, as long as you have the same thing on the top as you do the bottom. So what happens here is this 2 and this 2 get to cancel out because you had one on the top, one on the bottom. So now the only thing that we have left on the top is the 5. On the bottom, we have 3 times 3, which is 9. So what we're going to be doing is we're going to be following this method because we're going to be simplifying our expressions and canceling them out. Because what we don't want to do is we don't want to do a bunch of complicated FOIL only to have to factor it again to be able to simplify and cancel things out. So while this is good for numbers because you could easily divide 10 and 18 by 2, this makes it so much easier. You can simplify first. So to show you what this looks like with an expression, let's say that we have 5y minus 20 over 3y plus 15 times 7y plus 35 over 10y plus 40. So what I'm going to do is I'm going to simplify each one of these. So that means I'm going to factor. So that's where that factoring comes in again. All of these are not quadratics. So the only way that we can possibly factor is by taking out a GCF. So looking at the top, 5 and 20, the biggest thing I can divide by is 5. So that's going to leave me with y minus 4. And I always like to cancel out anything I simplify, so I'm just crossing that out. Down here, GCF of 3, so that's going to leave me with y plus 5. Over here, 7, so that's y plus 5. And 10 is going to leave me with y plus 4. Now, another thing that I'm going to do, which might be a little bit crazy, is 5, 3, and 7 are prime numbers. 10 is not. So I'm actually going to rewrite 10 as 2 times 5 and then my y plus 4. So now here's what I'm looking at. I have y plus 5 that get to go. And then I have a 5 and a 5. So again, it doesn't matter which fraction it's in as long as you have one on the top, one on the bottom. So now what we're doing is we're going through to see what's left. So I have a 7 and a y minus 4. Then on the bottom, I have a 2, a 3, and a y plus 4. So I'm going to do 2 times 3, which is 6, and then y plus 4. So I end up with 7y minus 4 over 6y plus 4. So you can see why it's important to be able to factor because a lot of factoring going on here. And like I said, this, it's called multiplication, but it's really, we're not doing a lot of multiplying. We're just using this idea that when you multiply fractions, you go straight across. So whatever is left, you're multiplying straight across. So 7 times y plus 4, 3 times 2 times y plus 4. So, there's not a whole lot of multiplication going on. And we don't want to jump straight into multiplying because I really don't want to do FOIL with 5y minus 20 and 7y plus 35 because we're going to get crazy huge numbers that would be way too difficult to factor again later. So here's another example. We've got x squared minus 5x plus 4 over x squared minus 1 times x squared plus 5x plus 4 over x squared minus 9. So I would encourage you to pause this and try it on your own just to see what you come up with. So to solve this, I'm going to go ahead and do my factoring first. So multiply to get 4, add to get 5. That's going to be 4 and 1, and they both have to be negative here. Over here, multiply to get 4, add to get 5. 4 and 1 again, but both positive. Down here, x squared minus 1, that's a special case, so it's going to be x plus 1, x minus 1. And this one's going to be x plus 3, x minus 3. So everything is factored. So now what I'm looking for are things that I have on the top and bottom that are the same. So x plus 1, x plus 1, x minus 1, x minus 1. Now, when I'm assessing what's left for my answer, I don't have to actually do the FOIL if I don't want to. So I'm going to leave it x minus 4, x plus 4, and x plus 3, x minus 3. The order of your signs doesn't matter as long as you have everything there that you should have there. But you don't have to do FOIL. You can leave it like that. and that would be considered our simplified version. So we'll do one more multiplication before we switch to division. So x squared plus 6x, 3x squared plus 6x minus 24 times x squared plus 2x minus 8 over x plus 6. Okay, so the first thing I'm going to do is go through and I'm going to factor everything that I can. So here on the top, the only thing that I can do is take out a GCF of x, and that's going to leave me with x plus 6. Here, I'm going to actually take out a GCF of 3 first, and that is going to make my factoring a little bit easier because now I won't have to do guess and check. So the 3 stays, then I can factor this. So multiply to give me 8, add to give me 2. So that's going to be 4 and negative 2. Up here, x and x. Oh, and what do you know? It is the same thing. So plus 4 minus 2. And this one actually doesn't simplify our factor at all. So here's what I have. X plus 4, x minus 2, x plus 6. So the only thing that I have left is x over 3. Okay, so lots of factoring. As long as you can factor well, this is not bad. All you're doing is factoring and canceling things out. So now, what does it look like when we divide? It's actually very, very similar. There's just one step that you have to remember. So if I wanted you to do 1/2 divided by 1/3, when you divide fractions, what you have to do is you have to remember to flip and multiply. So the second fraction gets flipped, so it becomes 3 over 1, and you change your operation to multiplication. Now it's multiplying just like we did on the front, which is straight across, so this ends up being 3 over 2. Okay? So what does that look like with an expression? Let's say that we have 6x plus 6 over 7 divided by 4x plus 4 over x minus 2. So usually what I do is I rewrite it first. I change my operation to multiplication, and I flip my second fraction. So second fraction, always the second fraction that gets flipped. Now, if you ignore this part, it's exactly like what we just did with the multiplication. So here I'm going to take out a GCF. Here I'm going to take out a GCF. Nothing else can simplify. And now anything top and bottom that's the same, you get rid of. So on the top, I have 6 and I have x minus 2. On the bottom, I have 7 times 4, which is 28. And actually, I should have thought about this a little bit better. I could turn 6 into 2 times 3 and 4 into 2 times 2 so that I could get rid of a 2 and a 2. So let me actually redo this. So now I have 3 times x minus 2 and 7 times 2, which is 14. Okay. So one more. X squared minus 3x minus 10 divided by 2x squared minus 11x plus 5 divided by x squared minus 5x plus 6, 2x squared minus 7x plus 3. So again, I would encourage you to pause the video and try this. I'm actually going to pause it and just write the answer down. So then once you unpause it, the answer will be there. Okay, so here's my factored form. I flipped the second fraction. I factored everything. So 2x minus 1, 2x minus 1, x minus 5, x minus 5, and that is all I have left. So x plus 2 times x minus 3, x minus 6, x plus 1.